Welcome to the Joy of Game Development, Pico 8 edition. In this panel, what we're going to do is build a game from scratch in under an hour. Obviously, with a time frame like that, it's not going to be a complete game. It's not necessarily going to be the best way to do things. What we're going to do is focus on getting a playable prototype up quickly. We're going to talk about the steps involved in that process. And we're going to talk about the choices that we could be making if we wanted to polish that game up later on. So what is Pico 8? Pico 8 is what's called a fantasy console. And all that really means is it's an emulator for hardware that never existed. It's not the only fantasy console out there. There are other ones. Some of them are paid. Some of them are free. Most fantasy consoles have basically all the constraints of a real retro console. So there's like Pico 8 is limited to 16 colors. You have to kind of pack your game into a very small amount of memory. But the difference is it has more modern development tools built in that make game development easier. So why would you want to use something like a fantasy console if it restricts you so much? The main reason is it helps narrow down your game development choices. So if you use something like Unity or Unreal, you're going to have to, like, you have options of using 2D versus 3D. You have the options of using lots of colors, lots of different sound and music options, shaders, online functionality. You can kind of spiral off into this paradox of choice. And that can kind of be difficult, especially if you're a solo hobby game developer. You end up in this paradox of choice where you're focusing on the details. Using a fantasy console can help sort of refocus you on kind of the bare bones of your game's mechanics. So Pico 8 is not free software. It costs $15. You can get it at lexaloffle.com, LEXALOFFLE. And interestingly enough, they also do educational licenses. So, for example, a friend of mine is using this to run an extracurricular group in the local school system and has bought a license for each of those groups, and they can just use it. And that's really good because because it's simplified, it's a good way to teach STEM and game development and that sort of thing. All right, so you'll see we've got the window here. When we start Pico 8, we get just a basic command prompt. We can type help to get a list of our options. Most of these are things like loading, saving, shutting down, things like that. We don't need to mess with that right now because we're starting from scratch. What we want to do is hit escape to get into our editor view. And you'll see we start out editor view in our code tab. We've just got a blank text editor here. If you look down at the bottom right, you'll see that we're limited to about 8,000 tokens, or essentially words, in our code. And we're also limited to about 64 kilobytes. In the top right corner, you'll see the different tools within the editor. So we're on the code tab. There's a graphics tab. There's a tile map editor. There's a sound editor, and there's a music editor. Because we're keeping this simple, we're going to stick with the code and graphics editors. So let's go to the graphics editor first. We're going to build a simple side-scrolling space shooter. So we really only need 3 graphics. We need a player ship, we need an enemy ship, and we need a bullet, something for the player to fire at the enemies. Again, really simple for this round. Like, we could go back and add more to it later. This is just the bare bones. So I've automatically got sprite 1 selected, and you'll want to remember that sprite ID because we're going to come back and we're going to use it later to reference this sprite in code. So sprite 1 is going to be our player ship. I've got my pen tool selected, white selected, and I'm just going to draw out the outline. And again, this is really simple. We're trying to get something up and running fast. Later on, we can come back and do nicer pixel art if we want. But this kind of just gives us an idea of what size our sprites are, what shapes, what it's going to look like. So, and you'll also notice there are a couple other tools. So for example, I'm using the fill tool over here to fill in those shapes. Then we're going to do a bullet for sprite 3. And we're going to make that blue so it fits with the player. All right, so that's our graphics. Let's go back to the code tab and we'll start writing some code. Pico 8 uses a language called Lua. You'll find, if you go to the website, under the resources tab, there is a user manual and a cheat sheet. This cheat sheet is really helpful for kind of remembering what different commands are. Because if you don't use it a lot, it's easy to forget. If you're used to things like JavaScript or C# or other, Python, more modern programming languages, there are a few things Lua does that may throw you for a loop because they're a little different. But mostly, if you know anything about coding, you should be able to pick it up pretty quickly. To start out with, we're going to create what's called a game loop. And a game loop is just functions that get called essentially every time a frame is rendered. And just over and over so that we handle each frame of our game. So I'm going to create a function called init, and that is a special name that tells Pico 8, run this set of instructions when my game starts. I'm going to create a function called update60. Update is going to run, in this case, about 60 or exactly 60 times a second. You can also just use a function called update if you want to do a 30 frame per second game. And this is essentially where we're going to handle input, move things around, kind of handle the state of our game world. There's also a function called draw, and draw is also going to be called about 60 times a second. And it's essentially what we're going to use to take the state of that game world and draw it as a frame on the screen. One nice thing about Pico 8 is it's very low impact. You can be pretty sure that you are going to get that 60 frames a second, and so usually you can just count in number of frames. You don't have to go back and take like a running total of how long the last frame took to render. If something does take longer than that, Pico 8 will drop some draw calls, and as a result, you'll just drop some frames. So, a couple things to notice here. Everything in Pico 8 is technically lowercase. I know it doesn't look like that, but there's not like an upper and lowercase difference. If, for example, I start putting on my caps lock, I'm going to get a bunch of special characters that I can use in, like I can use as icons in my game. So if you start typing and get a bunch of gibberish, that's what's happening. All right. So we've got our three functions, and remember, functions are just kind of reusable sets of instructions that we can call over and over so that we don't have to rewrite pieces of functionality. What we're going to do to start out with is we're going to draw the player sprite to the screen. And I'm going to create two variables, an X and a Y coordinate, to do that. What I want to do is put the player sprite on the left edge of the screen, just a little bit offset. And I also want to put it exactly center on the screen. So the Pico 8 screen is 128 by 128 pixels. If you're running larger than that, it'll scale up. And sprites are 8 by 8 pixels. So what I'm going to do is I'm going to start out the player at 8. So the coordinate system starts from the top left corner. Sprites are drawn from the top left corner. So the player ship is going to be essentially one sprite off of that left side. I'm also going to put our Y coordinate at 60. So the logic here is the screen is 128 pixels high. The middle of that screen is going to be 64. And then I'm going to go up 4 pixels, which is half the height of a sprite, to center the sprite exactly on that middle line. I'm going to come down here to our draw function. I'm going to start out each frame by clearing the screen. And then I'm going to call the SPR function, which tells Pico 8 to draw a sprite to the screen. And I'm going to say, draw sprite ID 1. Remember, that was our player ship. At the player's X and Y coordinates. All right. So I'm going to hit escape and type run to run this. So you'll see now we have our player ship on screen. I can press keys all I want. It doesn't do anything because we haven't told Pico 8 what to do with that sprite yet. So let's go do that. Let's go back and add some player movement. All right, we're going to go back to the code. And I want to keep my code nice and kind of clean and encapsulated. So I'm going to create a new code page here so it's kind of well organized. And I'm going to create a function called handle input. All right. And we need to find a way to get input from the controller. So let's go back and look at our cheat sheet. Pico 8 has essentially a 6-button controller. Imagine, for example, that you have like an 8-bit Nintendo controller plugged into this fantasy console. Now that controller can be mapped to your keyboard. It can be mapped to a gamepad or joystick, anything you want. But inside our code, we're going to treat all of these the same. We don't really care how they're mapped. So our left button is 0. Our right button is 1. Our up button is 2. Our down button is 3. And then we've got 2 action buttons, a circle and an X, which are 4 and 5. So what I want to do, I want to come in here to handle input. And what I'm going to do is say, if button 0 is pressed, then we're going to take the player's current X coordinate and we're going to subtract 1 from it. Because remember, origin is at the top left, button 0 is left, so we're subtracting from the player's X position. Actually, we can make this a little simpler. Instead of hard coding that 1, let's come in here and create a new variable called player speed. And let's just make that 1. And that way we don't have to retype. That way we can adjust the speed as much as we want. All right. So we're also going to say if the right button is pressed in a frame, then we're going to add the player's speed to player X because X increases as you go right. If up is pressed, we're going to subtract the player's speed from the player Y coordinate. And if button 3 is pressed, then we're going to add the player's speed to the Y coordinate. And all the minus equal and plus equal signs mean is just take whatever value is in that variable, the variable on the left, add the value on the right to it, and store it back in that variable. All right, so we've got that. Let's go to our update method, because remember, that's where we're going to update the game world. And we're going to call handle input. So let's run that. All right. Well, I can move it around. It feels a little slow for the size of the screen, size of the ship. So I'm going to hit escape to exit my game and go back into the editor. And let's bump up the player speed to 2. We'll basically have the player move at 2 pixels per frame. Yeah, that feels a bit better. And that's the advantage to using variables like that, is I can get the mechanics in place, and then I can tweak the speed and the feel of it until it's exactly what I want for my game. All right. So now, obviously, this is just a really basic way of handling input. We're not doing any speed up, slow down, any physics. We could always come back and do that, but for now, this is good enough to start prototyping the rest of our game. The first thing you'll notice if you start playing around with this is that the player can go off the screen. So if I hold down the right button, I'm just going to keep going. That X value is just going to keep going up. So we've got a game where it is possible for the player to get lost, and that's not a good experience. That's confusing. So let's go back and let's limit our player to the screen. We're going to do that with a function called mid. We're going to do all our updates to our X and Y coordinates, and we're going to use a function called mid. So what mid does is it takes 3 values and it returns the middle value. So we're going to give it our player X coordinate. We're going to give it 0 for the left side of the screen. And we're going to give it 120 for the right side of the screen. Remember, we want the player sprite all the way on. We never want it to get like halfway off the screen. So we take that right coordinate of 128. We subtract the width of a sprite, which is 8 pixels. And so X will stay within 0 to 120. The way mid is going to work is if our player X is greater than 120, then 120 becomes the middle value, and that's what gets returned and stored back in X. If it's ever less than 0, then 0 becomes the middle value, and that's what we're going to store back in our player X variable. Otherwise, we're just going to get whatever we had there to begin with. So we're going to do the same thing with our player Y and run the game. And now we stay within the bounds of the screen. So we've got player movement pretty much done. What's next? So we're making a space shooter, so we want to actually be able to shoot. So let's create bullets. Okay, to keep track of our bullets, we're going to create what's called a table in Lua. A table can represent either a list of values or it can represent a collection of values that each have names. So think about like a database record or a row in Excel. If you're familiar with arrays, dictionaries, objects and lists in other languages, well, it's kind of all of those concepts mashed into a single thing, which again can be a little confusing, but it works basically the same way. So we're going to create an empty table called bullets. We've got opening and closing curly braces just tell us that this is a list and we're not putting any items in it. All right, there's a lot of stuff we have to do to get bullets working. Let's start out with 2 things. We want the player to be able to create new bullets, and we want to draw those bullets to the screen. So first, let's go to our handle input, First, let's create a method called spawn bullet. And we're going to pass that method, or we're going to pass that function an X and a Y coordinate. And what we're going to do is we're going to create a new table to represent the bullet. It's going to have a property called X and a property called Y, and those are just going to be equal to the values we got passed in. Then we're going to take that table and we're going to add it to that bullets table that we created. Now you'll note this is kind of the simplest possible bullet we could use here. We're just storing the X coordinate and the Y coordinate. If we were making a more polished game, we could do some fancier things. We could give it a sprite ID if we had different weapons, so that depending on what weapon you were using, it draws a different projectile to the screen. We could store how much damage it does. We could even give a property that is another function that tells how it moves across the screen. So there's lots more that we could do with this, but again, we're keeping things simple so that we can build something in an hour. So we're going to take that method. We're going to say if button 4 is pressed, or if button 5 is pressed, because again, we're not doing much here. If the player presses either of the action buttons, we want it to fire. You know, we're not going to have different functions for those two buttons. We're going to call spawn bullet, and we're going to pass in the player's X and Y location. So we're going to spawn the bullet at the location where the player currently is. The next thing we want to do is be able to draw those bullets to the screen. And so we're going to create another function called draw bullets. And that way, you know, we're not cluttering up our draw function with, you know, a lot of specifics. We can just plug in draw bullets and it's handled. In draw bullets, what we're going to do is we're going to loop through that table of bullets. So when we say for B in all bullets, what we're saying is step through the code in this block with each bullet in that list, where B is going to represent the, you know, each bullet in the list. And all we're going to do is we're going to call that sprite method, and we're going to pass in sprite ID 3, because remember that was our bullet. And we're going to take the bullet's X and Y coordinate and pass that into sprite. So in our bullet table here, we created an X property and a Y property. Now we're saying B.X and B.Y to use those properties, where B is representing the bullet. All right, so we're going to go back to draw, and I'm going to add draw bullets here. I'm actually going to add that before we draw our player ship, so that the player ship gets drawn on top of the bullets. All right. And I'm going to do one more thing. I'm going to add some debugging here. I'm going to add a print statement, and I'm going to say, show the number of items in that bullets list at the top left corner of the screen. So it's kind of hard to see here with the font, but this is like a pound or a hash sign. And all that says is show me the number of items that's in this table. All right, so we're going to go back and run. Now if I hit X, it's just going to create bullets like all over the place. And they aren't going to do anything, because we didn't tell them what to do. We just said, create this bullet and draw it to the screen. So what we need to do is add in some logic that moves the bullet across the screen and then deletes it from the list once it's off screen. And the way we're going to do that, again, to keep things clean, we're going to create a function called update bullets. And it's going to be sort of similar to our draw bullets function. We're going to say for each bullet, we're going to take the X value and add a bullet speed. And I'll go ahead and create a variable for that so that we can tweak that later on. I'm going to make that 1 for now. And then we're also going to do a check. We're going to say if after moving the bullet, the X value of it is greater than 120 or 128, if it's completely off the screen, then we're going to delete that bullet from the bullets list. And now that we've got this logic for our bullets, we're going to come in here to our update function and wire it up. So anytime we do an update, we're going to update our list of bullets. We're going to handle our inputs. All right. So now you'll see this is a little bit better. It's still a lot of bullets, but they're moving off the screen. Oh, I did something wrong here. You'll see that 439, that's not going down. Those bullets aren't getting deleted. Let's take a look at that and see why that's happening. Oh, it's because I typed in bullet here instead of bullets. Our table name is bullets. All right, now that works. So as soon as my bullets go off the screen, you'll notice the number here goes back down to 0. Again, we've got functional bullets, but 1 bullet per second is a little much. Like that's just too much to deal with. So what I want to do is I want to add a timer, and essentially we're going to be giving that fire action a cooldown. When the player fires, it's going to set that timer and keep ticking it down to 0. And until that timer hits 0, you can't fire again. So to do this, we're going to add in a couple of a couple different variables. We're going to create a bullet fire rate, and we're going to start out saying 10. So once the player fires, 10 frames have to pass before they can fire again. And we're going to set a timer at 0. Now again, we may come back and decide we want this to be faster or slower, but right now we'll do 10 just to see how that feels. All right, and to keep my handle input function clean, I'm going to create another function called handle firing. And what it's going to say is if if bullet fire timer is greater than 0, then we're going to subtract 1 from the timer, and that's all we're going to do. And we're going to say else if. So if bullet fire timer is not greater than 0, if it's 0, and the player presses either button 4 or button 5, then we're going to spawn a bullet, exactly like we were doing before. And we're also going to reset the timer to whatever the fire rate was. So what'll happen is, let's kind of think through this. When we start the game, our timer is going to be 0. I'm going to hit an action button. We're going to create a bullet, and we're going to set the timer to 10. The next frame, we're going to come through handle firing, and we're going to say, okay, that timer is greater than 0, so just tick down and don't allow the player to fire. Timer's 9, 8, 7, 6, 5, 4, 3, 2, 1, and 10 frames later, the player will be able to fire again. So we're going to replace our previous logic in handle input, and we're going to run our game. So now, that's a little bit better. That's a little more manageable. And of course, we could come in here and say, well, I really want this to be more of a bullet hell game, so let's change our fire rate to 4. And those bullets are also going slow. Let's change our bullet speed to 4. Okay, no, that's more like a bullet hell game, isn't it? All right, that's a little faster than what I want here because again, we're making a really simple game. We're not going to have a lot going on. I'm going to leave my bullet speed as let's back it down to 3, and I'm going to leave my fire rate. I'm going to bump that up to 20. So every 20 frames, you'll be able to fire again. So that's going to work out to 3 bullets per second. Okay, that's decent. All right. So we've got bullets that we can fire. Now we need something to fire at. So we're going to need to create enemy ships. And I'm going to start out kind of like we did with bullets. I'm going to create a table called enemies that's going to keep track of the enemies that are currently on screen. And I'm actually going to pre-populate that with an enemy for now so that we can kind of test this out. I'm going to set the enemy at 120x, so up against the right edge of the screen. And I'm going to set the enemy at 60. So it's going to be at the same vertical position as our ship, just at the other side of the screen. And I need to close that table. So you'll see these outer curly braces are the entire enemies table. The inner curly braces here are just that single enemy that we're creating. All right. We also need an enemy speed value. So I'm going to set that to 1 for now. And to handle enemies, I'm going to create a new function called update enemies. And this is actually going to be so similar to our bullets. I'm just going to copy the bullets code out and reuse it. So I don't have to type all of that again. So what I'm going to say is I'm going to say, let's loop through that table of enemies. For each enemy, we're going to subtract, because remember it's moving left, so X has to decrease. We're going to subtract the enemy speed from each X position. And then if the enemy X ever gets less than -8, we're going to delete it from the enemies table. So it's just going to go away because now it can't hit the player's ship anymore. You may be asking, why am I using -8 here? Well, let's think about that. Like, the left edge of the screen is 0, and I want the enemy ship to be all the way off the screen before I remove it and stop drawing it. Sprites are 8 pixels by 8 pixels, so when X hits -8, it will be fully off the screen and will be safe to remove it. All right, so I'm doing update enemies. I also want to draw enemies. And again, we're just going through everything in that enemies table. And for each of those enemies, we're going to draw sprite ID 2, because that was our enemy ship, at the enemy's X and Y location. Again, right now we're only storing the X and Y coordinates of the enemy. We could add, if we wanted to add new types of enemies, we could add a sprite ID. We could add the point value, like the amount of points you're going to get added to your score if you kill the enemy. We could add a health value if we wanted to be able to create enemies that took multiple hits to take down. But right now we're just trying to build something really simple. We can always go back and add that in later. So we've got our update enemies function and our draw enemies function. We're going to come back to our game loop, and we're going to update enemies during the update step, and we're going to draw enemies during the draw step. So let's run. All right. Okay. the enemy flies toward the player off the screen. So it's doing what we told it to do. You'll notice that I can't kill the enemy, and I can't. The enemy can't kill me from running into me. So the next thing we're going to have to do is implement collision detection. All right, let's go back into our code. And I'm going to create a new code tab here because this collision detection function we're going to write is more of a general utility function that's going to get used all over. It's not really part of the game loop, and that's kind of how I'm organizing my code here. So we're going to create a function called isColliding. isColliding is going to take two rectangles, and each rectangle is going to have an X and Y coordinate representing the top left corner, and it's also going to have a width, and it's going to have a height. And if we've got those four pieces of information for each rectangle, or those 8 pieces of information, we should be able to determine whether they overlap. So we're going to have an X1 parameter, Y1, W1, H1, and we're going to have an X2, Y2, W2, H2. And what's going to happen is we're going to take those values in, and if the two rectangles are colliding, we're going to return true. If the two rectangles are not colliding, we're going to return false. And this way we can check for collision anywhere we need to in our code without having to rewrite that logic. So let's kind of think about this. How is this going to work? Imagine you've got two rectangles. Imagine what they look like if they overlap versus if they don't overlap. So if the left side of any one rectangle is further right than the right side of the other rectangle, they aren't colliding. If the top of one rectangle is below the bottom of the other rectangle, then they aren't colliding. If either of those are true for either rectangle, there's no collision. Otherwise, there is a collision. So how are we going to write this? So we're going to say return a value, and it's going to be a true-false value, and we're going to say if the left side of the first rectangle is, we're going to return true only if the left side of the left rectangle is to the left of the right side of the second rectangle, and the left side of the second rectangle is to the left of the right side of the first rectangle, and the top of the first rectangle is less than is above the bottom of the second rectangle, and the top of the second rectangle is above the bottom of the first rectangle. So, yeah. That's kind of tough to envision. I'm going to double check this because in a previous take I did of this video, I got it completely wrong and didn't notice until much later. Yeah, there we go. All right. So I'm using the X coordinate and the width to get the rightmost X coordinate, and I'm using the Y coordinate and the height to get the rightmost Y coordinate. So we can take this function and pass in two sprites. If it returns true, they're colliding. If it returns false, they're not colliding. So first, let's see if the enemy gets hit by a bullet. So we're going to come back into our update enemies. And what we're going to say is for B in all bullets. So every time we check an enemy, we're going to also check that enemy against all the bullets that we're keeping track of. And we're going to say if the enemy So XY 8x8 pixel is colliding with a bullet, XY 8x8 pixel. Then we're going to delete both the enemy and we're going to delete the bullet. So kind of imagine what this looks like. Bullet flies into the enemy disappears, bullet disappears. And we're going to stop there because if one bullet hits the enemy, that's all we need to check. We don't need to check every other bullet. And again, this is a really simple example. If we were polishing up this game, we would add probably a sound effect. We would probably add some sort of particle or sprite effect that indicated that the enemy had been killed. We might use this to add points to the player's score or, update a mission objective or something like that. Right now, all we're going to do is get rid of the enemy and get rid of the bullet so that it feels right. All right. So let's run our game. We shoot the enemy and it goes away. So that's pretty good. You'll also notice, though, that we can still fly through the enemy and nothing happens to us. So let's fix that. We're going to come back to update enemies, and we're going to, now we've been checking the enemy against all the bullets, now we're going to check the enemy against the player. And we're going to say if that enemy sprite, 8x8 sprite, is colliding with the player X and player Y, and an 8x8 sprite. And again, I can hard code that 8 pixels by 8 pixels, but I want to be able to reuse this function no matter, if I decide to double the size of my ships, this function would still work. I could still pass in whatever I changed my sprite size to. So if the enemy collides with the player, what do we want to do? Well, that's kind of our game over state, right? We just want to stop playing. Now, if we were going to polish up this game, we might do a game over screen. We might subtract player health or player lives, something like that. But all I want to do is just kind of stop the game. We'll have to hit escape to get out. We can run it again. To do that, I'm going to create a variable called isPlaying. I'm going to default that to true. So if we collide with, if the player collides with an enemy, we're going to say, nope, the game is over, or isPlaying is now false. Again, we might use this to do a game over screen or something else later. We're not going to get that fancy right now. What I'm going to do is I'm going to come to the our update function. I'm going to say if isPlaying is ever false, then just return. Just stop executing the update right there. Don't touch the enemies. Don't touch the bullets. Don't handle player input. Just stop executing. And again, what we would probably want to do here is, if we were polishing this up, allow the player some way that they could reset the game and all that. This is good enough for our really simple intro here. So we're going to run the game. I run into the ship and the game stops. I can't do anything else. I have to hit escape to get back to my command prompt. So now, we've basically got a fully functional game. We can shoot the enemy ship, which is our win condition right now, or we can run into the enemy ship, and that's our lose condition. So I mean, we've got all the basic elements that we need, but obviously that's kind of boring. It's kind of boring to play a game that only has one enemy. There's a couple of things we could do. So if we wanted to build, build out different missions or different levels, we could pre-populate this enemies table with like just a complete wave of enemies that are just going to come on screen, and you're going to have to avoid or shoot. I don't really want to get into level design right now because that's kind of where we're going. So instead, what I'm going to choose to do is create an infinite spawner. So what's going to happen is every so many frames, we're just going to pump another enemy into that enemy's table. So and we'll clear out the enemy's table in preparation for that. All right, so this is going to look a lot like our bullet timer. We're going to create a variable called enemy spawn rate, and let's say one every second. And we're also going to create an enemy spawn timer, and we're going to set that to 0. So what I'm going to do is I'm going to create another function called spawn enemies. And again, this is going to look a lot like our handle firing function. I'm going to say if enemy spawn timer I'm going to say is less than or equal to 0 because that's what we're starting out with. Or actually, no, let's say if it's greater than 0, then we're going to subtract 1 from the timer. All right. So if we've got any seconds on the clock, we're just going to keep ticking down. And if we hit 0, we're going to create an enemy. And again, this is going to look like when we created a bullet. We want that enemy's X position to start out at 128 because it starts out at the right side of the screen. And then we want the Y position to be random between the top and the bottom of the screen. So what we're going to do is we're going to set Y to the output of a function called R&D. And what R&D will do is it will give you a number between 0 and whatever number you pass into it. So we're going to say, give us a number between 0 and 120. And again, why 120? Well, the screen is 128 pixels high. We only want enemy ships to be fully on the screen, so they can't spawn anywhere below 120. Otherwise, they'd be cut off by the bottom edge of the screen. So we've got our enemy ship. Starts out at the right side and at a random vertical location. We're going to add that to the enemies table. And then we're going to reset the enemy spawn timer to whatever the spawn rate is. We're going to take that and we're going to add that to our update function. And we're going to run our game. So now you'll see every second we get a new enemy. And that'll just keep going forever. Let's take out our debugging here. Now again, we've got a lot of variables we could play around with here. If we want the game to be faster paced, so for example, we want to make a bullet hell game, we're going to bump that bullet fire rate up to once every 5 frames. We're going to bump the enemy spawn rate up to once every 10 frames. And we got a bullet hell shooter. The enemies are a little slow in that case, so let's bump those up to 3 as well. Yep. We got a bullet hell shooter. So you can kind of use these variables to play around with and figure out what exactly do you want the speed of your game to be. And that's kind of the first bit of polish you can add. Now, obviously, if we wanted to finish this game out, we could do a lot more. We could come in and add different types of weapons and enemies the way we've talked about. Add some different, add some new properties to those bullet and enemy objects. that tell you what sprite to use, what flight pattern they use, how much damage they do. We could do some things to tighten up our ship controls. We could actually, as we said, we could go through and build out levels that are just waves of enemies that pre-populate that enemies table every level. There's a lot we can do, and if we've structured it well, with functions and variables and stuff like that, we shouldn't have to go in and touch too many pieces of code to make it work. Anyway, that is our game. That's the joy of game development, Pico 8 edition. Thank you for watching.